let's see one very important no placement question or an important coding question which can be solved using stacks efficiently, right? That is, the problem is stock span problem. Okay, so generally in stock market, in the stock market, people do lot of analysis to make profits, right? So this is one kind of a problem which is used to identify the span in a stocks, right? So since the stock market terms are new, I will try to little give information about this problem, and then we will see what is the standard solution for this and what is an efficient solution which we can solve using stacks. Okay, so generally in stock market, when I want to make some predictions, right? When we want to make again, stocks is kind of you invest some money, you purchase some stocks like Reliance company, just an example. You purchase some stocks of this company. One stock, maybe you purchase this for 100 rupees, for example, right? And you want to you have purchased it. What generally people do in stock market, they'll purchase stocks, they'll purchase the stocks, and whenever they observe that the stock price has gone up, they will sell it. Okay, whenever the stock price has gone up, they will sell it. So suppose on 1st January, okay, 1st January, I purchase a stock, one stock of and its worth is rupees 100. Then on 31st January, right, whatever monthly profits this company made, based on this, the same one stock worth may become something like this, 125, right? So you have made a profit of 25 rupees here over one stock. Since you purchased only one stock, you in 1 month you made profit 25. How did this 25 come? This 25 came, it depends on many factors of this company, right? Lakhs of people will purchase stacks of Reliance and they will be selling the stacks of that company, right? So considering multiple factors, it becomes okay. There is also some chance that on maybe on 10th February, this same one stock value became rupees 97, right? It has gone down now, 28 rupees, it has gone down, right? It keeps fluctuating depending on the market, depending on the profits and loss made by some organization of whom you purchase the stocks, right? So this is general pattern. They'll purchase hundreds of stacks of different companies and they make huge profit. And sometimes when the market is down, suddenly the stock value comes down and it is very less. So you get losses there, right? This is general scenario of the stock market, right? So in that we have one problem. What is that? What is this stock span, right? So same example, one stock I purchased for 100 rupees. This is on first day. On second day, same one stock, it became maybe some 80. It came down 80 rupees. On day 3, it became 60 rupees. On day 4, it became 70 rupees. Right? Now, what is this span? What is this stock span? It means, see, whenever we have to find out number of days. Okay, number of days the stock price was less than the current day. Number of days the stock price was less than the current day. Meaning, see, day one, that's only the one stock you purchased that day only. So there is no change in the profit or loss. Day 2 you take. Okay, so the current day, today is day 2. Today's price is 80. Okay, is the previous day less than 80? That I have to check. Is it less than 80? No, it is not less than 80. Right? Then day 3, I got 60. Right? So stock span means finding out number of previous days. How many days was the stock value lesser than the today's value? How many days was the stock value lesser than the today's value? So today's value is 60. Was the previous day's stock value less than 60? No. Again, day 4, I have 70. Was the previous day's stock less than 70? Yes. So we count it as 1. We count it as 1. Right? Again, you have to check all till 100. You have to check. You have to check till 100. So 60, then 80 came. It means it's failed. So only one day. Current day value is 70. Right? Stock span value is 1. Why? Previous one day it was less than 70. So again, day 5. You take day 5. Okay. So it became some 85, for example. It became 80. So current day price is 85. Current day price is 85. Now the question is, what is the span? How many previously, how many days where the stock value is less than 85? See, 85, you go to previous 70, it is less than 85. Again you go back 60, it is less than 85. Again you go back 80, it is less than 85. Again it go back 100. No, it means current day value 85. No, day 5. On the current day, from the current day, previous 3 days the stock value was less. It means today it increased. It means today the stock value increased. Okay, what is the span here? Span is 3. Span is 3. Why I need this span? Let's understand this detail. Why we need to worry about span? I'll take this example: 180, 180, 60, 70, 60, 70, 60, 75 and 85. Okay, right. Why I have to verify that? Let's see. First day 100. First day it is 100. So we don't have any previous day. We'll put that by default as 1. Okay. Next day it is 80. Is the previous day of 80 less than 100? Less than 80? The previous day's stock value. Today is 80. Day 2 it is 80. Was the previous day stock value less than 80? No. Just put 1. Okay, today is the day 3. On that day, the stock value became 60. Was the previous days, all the previous days stock value less than 60? No, put 1. Here, 70. Today is day 4, right? And the price is 70. How many days in previous 3 days was the stock value less than 70? You check 60. Yes, it is less than 70, right? Then you go to 80. Is it less than 70? No. So you have to put it 2 here. Okay, because why 2 I am including here? Because this index minus this, actually this index minus this 80 index. It means consecutively 2 days, the stock was little increasing order. It was an increasing order, 60, and then it increased to 70. Or maybe I can take it as no, all these 3 values as 0 also. There is no difference. Yes, it is. The span is 1 day. The span is here 1 day. Why I kept 1 here? Because previous one day, the stock value was lesser than the 70. Then come to 60. Here 60, check back the previous element. What is the span here? Is the previous day stock value less than 60? No, put 0. Then came 75, right? Our day 5, day 6. On day 6, you check the previous stock values. Previous, is it less than 75? Yes. Again, 70, is it less than 75? Yes. Again, less than 60, less than 75? Yes. Again, we got 80. 80 is less than 75? No. So consecutively, how many days was this stock value? How many days was the stock value lesser than 75? It was 3 days. It is 3 days, right? Over. Next, we got the next number as 85. Last day, I want to sell the stock. 1 week data, I want to sell the stock. Today, the stock value is 85, right? So check how many consecutive days, the stock value of today's, that is 85. The stock values of previous days were lesser than this today's value 85. So 75 is less than 85, 60 is less than 85, 70 is less than 85, 60 is less than 85, 80 is less than 85, 100 it failed. So how many consecutive days the stock price, the stock value was less than 85. 1, 2, 3, 4, 5. 5 days, right? So this is your stock span. This is your stock span. Okay, but again, since we count that day also, we don't consider it as 0, we make it as 1. So it is 1, 1, 1. This becomes 2, this becomes 1, this becomes 4 and 6. Why? That same day, no, I am checking the first condition. Day 1 is 100. Day 1 is 100. How many previous days are there? If there is no previous day, then you have to put it 1. Actually, that is the logic here. So this is your actual stock span. Now, why I need to use this stock span? See, this gives you some hint. This gives you some hint that today, if I take 1 month span, for example, if I take whole 1 month span, right, I can make some analysis. This 1 week span, you see the 85. Day 7, the stock price was 85. Is it better to sell the stock or not? Is it better to sell the stock or not, right? Or can I purchase some new stocks or not? If you see, this 6 means, it means consecutively last 6 days the stock was very bad. Today only it has increased a lot or little. There is some growth, right? After so many fluctuations, today the stock price increased. It means today's value is highest in the last 6 days. Okay, like this, if you do stock span for 1 month, what will happen when you do it for a whole month? What will happen there? I will get so many. No, I get like this 1, 1, 1, 2, 1, 4, 5, 6, 7. I may get 1, 1, 1 again. I may get 12, right? Again 1, 1, 1. I get 15 here. It means 15 days highest stock is today. Then it means last 15 days. Today is the highest day. I can sell it. I can sell this stock to make profit. Okay, so to give insights about when to sell and when to purchase a stock, we use this stock span logic. Okay, I'll repeat that with another example. Here we have 10, 4, 5, 10, 4, 5, 90, 120, 80, 120 and 80. Okay, day 1, this is day 1, the stock value is 10. So we will put the span value as 1, because that day itself is the first day, so it is 1. Then day 2, I have value 4. Check if the previous day's stock was less than 4. No, put it 1. Then I have 5. Day 3, I have 5. Check if the previous day's stock was less than 5. Yes. Again, check if this other day 1, this also you have to compare. Check if 10 is less than 5. No. So how many? 2. Only 2 times. The fourth day, the day 2 and day 3, the stock is increasing. 4 to 5. Then came 90. On day 4, I have the stock price as 90. Now check the previous day. Is it less than 90? Yes. Again check previous. Is it less than 90? Yes. Again check previous. Is it less than 90? Yes. So total how many days the stock price was less than 90? It is 4, including that day. Then came our 120, right? Then we got 120 here. So I'll make it 4. Yes, 120. Check the previous day. It is less than 120. This is also less than 120. This is also less than 120. This is also less than 120. Right? So the span value is 5 here. It means consecutively 5 days the stock price was lesser than the today's date. Okay, that you have to include that day also. Right? Then came 80. Check it the previous. Is it less than 120? No. You have to put it 1 here. That's it. Stop there. Why? We are looking for consecutive days, not alternate days. So the previous day itself was high and today it is low. So put it 1 like this. You see 1, 2, 2, 4, 5, 1. 1, 1, 2, 4, 5, 1 is the solution. Right? So how do we solve this problem? Okay, this is the logic of stock span. How do we try to solve it? Right? Let's again try to analyze the code. How do we write the code for the stock span? Generally in the methods of using array, because we are giving an input n, that is size of the array, and you are given the elements into an array, right? Then you have to predict this stock span, you have to predict it. So how we do it? Let's analyze the logic. Let me take down those numbers again. 100, 80, 60, 70, 60, 75, 85. This is the given array for us, right? What can we do? See, let us make one analysis here. If I put them in an array, like this. If you see, and let me write the result also. It is 1, 1, 1, 1, 1, 1, 2, 1, 4, and 6. Right? This is the result. If you observe here, see, if I start iterating from index this, let me write indexes also. If I start iterating from this index, right? Check if this 85 is 75 is less than 85, you increment the counter. Then if 60 is less than 85, makes again C++. 70 is less than 85, C++. 60 is less than 85, C++. 80 is less than 85, C++. 100 is less than 85, no. Whenever it stops, you stop the process, iteration, you stop it, and you fill the value here. What I am doing here, see, I am taking a count value as 1 initially. So I will erase this answer now. I will initially declare some C equal to 1. Now I'll write the logic in reverse order. For some I is equal to n minus 1, I greater than or equal to 0, I minus minus. Okay, I'm doing it in reverse order. I'm starting from 85. Now again, since I have to repeat it multiple times, I will take another for loop. So for some j equal to, j should be I. Okay, j less than or equal to 0, j minus minus. Right? If a of this is fixed, this is I. If a of I is greater than or equal to, again, equal to case is a typical case, but will still be included here, is equal to a of j, right? So here you can put j as I minus 1, sorry, I minus 1. Okay, so what is a of I now? See, I value is 6, j value is 5. I am checking if a of 6 is greater than or equal to a of 5. Yes, 85 is greater than 75. You do C++. Right? Again iterate, j minus minus, j becomes 4. If a of 6 is greater than a of 4, this value 60, yes, it is greater than, then again C++. So C became 3 this time, it became 2 and then became 3. Again, j becomes 3, that is 70. Is 85 greater than 70? Yes, make C++, C becomes 4. Again, j becomes 2 this time, so that is 60. Compare 60 with 85. Is 85 greater than 60? Yes. So C++. So C becomes 5. Compare this 80 with this 85 because j becomes 1 this time. So 80 is less than 80. Is 85 greater than 80? Yes. C becomes 6. Okay. Then j becomes 0. Again, 100 is 100 greater than or equal to 85? No. So it will not go into this logic. It will come out of the loop. What is the count value? We got 6. That you insert it into another array. You take another array to maintain the span values. Where you have to keep it? If this is a span array, you just put s of I equal to c. That's it. Why s of I? I value is n minus 1 in the first iteration. That is I value is 6. In s of 6, place 6 value. Then I becomes minus minus. So this time I will become 5. When I becomes 5, j becomes 4. J will become 4. Now I have to compare a of 5 with 4 and repeat this process. But again, I want to make my c is equal to 1. So I am putting that inside the I for loop. Why? This c should become nullify again. It should go back to the original value. It should not count from there. So again, the c value should become 1 like this. So now I is 5, j is 4. Again, compare 75 is 60 less than 75? Yes. 70 less than 75? Yes. 60 less than 75? Yes. 80? No. So 4 times. It will increment 4 times. But why? Because C already is 1. So 3 times it will increment. C becomes 4. Again, I becomes 4. This way it will repeat the logic. Right? So this is one solution for this stock span problem. What we are trying to do here, we are trying to take the last element. There are multiple solutions. For this problem. Okay, you take the last value and keep comparing till you reach 0. Again, you start from 5, keep comparing till 0. Start from 4, keep comparing till 0. Like this, you repeat the process and you try to do it. But if you see the time complexity here, it is order of n square. Why? I'm using 2 for loops here. Complexity is very high in this approach of solving it using arrays. Using 2 for loops, if you solve it, it becomes little complex. The time complexity is order of n square. But how do we predict this in lesser time stamp? That we have to find it out. Okay. So let's understand the same, no, for the same problem, let's see how we can reduce the time complexity of that no solution by using stacks. So if you remember, when we discussed the stacks, we wrote this as one of the applications in the stacks, right? Applications of stacks. Somewhere I mentioned it, different applications. Yes, see, we have seen that no finding of spans. This is one major application of stacks. So we can do that using stacks. Let's try to understand how we can do this using stacks. Okay, same data I will take 100, 80, 60 problem, 100, 80, 60, 70, 60, 75 and 85. These are the stock values on different dates. Again, it's a small number, small 1 week data is given to us. We have to solve this problem. What I have to do? I have to find out the span of each day. What is the span of each day, right? So if you see, we are actually comparing in the array based solution which we discussed just now. We are actually comparing in the reverse direction. No, we are comparing it in the reverse direction, right? From 85 I'm beginning, I'm doing it in the back direction. It means, which is one data structure where you can play with the reverse, it is stack. If I can store these elements in a stack and perform some operation, then it becomes more interesting and easier, right? Let us analyze. Let me take a stack here. Okay, with the help of a stack, we will try to do this. Let's see how we'll do it. Okay, so this is the array which I have with me. Right, now I have a stack with me. For now, maybe this is empty, so I will just remove these things. It is empty stack now. So what I have to do here? Take one index value. Okay, take again top value will be -1 because initially the stack is empty. This is my array A, right? So after this, what we'll try to do? We will try to initialize. I will take one more array. I will take one more array. That is my solution array. The span array of same size, right? For 7. So it is 0, 1, 2, 3, 4, 5, 6. Initially for day 1 we already know. Day 1 by default it is 1. Initially we already know for day 1 it is 1 because there is no other previous day. So we put it as 1. Now insert the index. Okay, try to understand the solution. It will take time for you to understand, but you just see how I'm explaining. Maybe in few minutes you'll understand it, but see, observe the steps what I'm doing here. Okay, initially I kept it 1 here because for the previous day there is for the first element there is no previous day, so I kept it as 1. Then here we have this 100, right? When you have this 100, you insert the index of the first element here. Let us put it 0 there. Why I kept 0 here? Because that is the only element we have till now. Day 1, this is the state of the span array, and this is the state of the stack. Then day 2, what is the current element now? The current index is 1 and current element is 80. Current element is 80. Compare the current element. Compare the current element with the current top of the stack value. It means compare the current element 80 with stack top of the array A of stack top. What is there in stack top? 0. Okay, array of 0, 100. You are comparing 80 with 100. You are comparing 80 with 100. Okay, you will take time to understand the solution, right? So you're comparing 80, the current element 80 with 100. What happened here? What happened here? Is it less than that? No, it is not less than. So I will also put 1 here and insert this elements index here like this. Why I inserted 80? Your job is to iterate over the array elements, take every element, compare it with the top of the stack. Compare it with the top of the stack element. After comparing, if that is not less than, just put 1 here and insert the element index into the stack. Now this 1 has come here and 1 also came here. Next, what is the third element? My current index is 2 and my current element is 60. Current index is 2, current element is 60. What I have to do, the condition, check the current element with the current element of the stack top. What is there in stack top? We have 1. Array of 1 means 80. So you are comparing 60 with 80. Okay. So again, it is not less than that. 80 is not less than 60. So I'll put 1 here and insert the index 2 here. I am storing only the index, not the element. Be careful. Now we will see the actual logic. See, now I iterated over the array, we came at 70. So the current index is at 3 and current element is 70. Now what you have to do? Compare the current element 70 with the stack top element. What is stack top element? 2. Again, stack top contains 2. Array of 2 means 60. Compare this with 60. Compare that with 60. Right? Then this span, here you will insert zeros initially. Okay, here you will insert zeros. The span of Ci, that is current index, right? Whenever this 70 is this 60 is less than 70, I'll just increment it and I'll pop this element. Okay, then again, when the condition is true, again I'll go back and compare this 70, the current element 70 with the stack top element. So compare 70 with this time. So because of this, previously this became 1. Okay, current index is 3 still. 70 with array of 1, that is 80. Array of 1, that is 80. Is it less than 1? Is it less than is 80 less than 70? No. Since it is not less than 70, we will proceed further. We will not do any change here, right? So but we did one plus plus. Initially it was no, because of this will become 2 here, right? So I just maybe I think default we have to put it 1 here, not zeros. We have to put it 1 here by default. Okay, next you take next element. Let's proceed. I'll repeat this once again. So the current day is this, that is my current index is 4, current element is 60. Okay, so what is there in stack? And we have to insert 70 here. No, what is that index? Index is 3. We have to insert this index. Once the comparison is over, we have to insert that back onto the top of the stack. Now the current index is 60. Okay, now compare this 60 with the top of the stack index element. So what is top of the stack? 3. A of 3 is 70. Compare that 60 with 70. Is it changing? No, 70 is greater than 60. So there is no change here. You insert the index 4 into this. Then came 75. So my current index is 5 and current element is 75. Now compare 75 with the top of the stack element. What is the index here? 4. What is A of 4? 60. 70 with 60. What happened here? It is matching. It is 60 is less than 75. Then you increment this value, it becomes 2, and pop out this element. Okay, or there can be multiple logic. Even if you don't increment, just pop out the top element. Again, compare this 75 with the topmost array element, that is 3. Topmost array element. A of 3. What is A of 3? A of 3 contains 70. Is 75 less than 70? Yes. Just pop out this array element. Now again, you compare it with the top of the stack. What is there in top of the stack? 1. Is 75 less than 80? No, here it failed. 80 is 80 less than 75? No, it failed. It failed. So simply subtract the current index with the top of the stack value. Subtract them both. So this becomes 4. Subtract the current index value and the top of the stack. So this becomes 4 here. After that, what I have to do? I have to insert the index value 5 here. Why? Whatever you are comparing, you have to insert it back. Again, iterate. The current index becomes 6 this time and current element becomes 85. Okay, where is my top of the stack? Top of the stack is at 5. Top of the stack contains, this is my top. Now, what is the logic? Compare 85 with the element at the top of the stack. What is that A of 5? What is A of 5? 0, 1, 2, 3, 4, 5. 75. Is 85 greater than 75? Yes. In that case, I have to just pop out the element. Now, this is over. Again, is 85 less than the top of the element, that is 1. See, we are skipping the 60, 70, 60 again. That is the advantage of using stack here. We are just comparing with the 80. Why? Because we know already that the topmost element less than 85 is on the top of the stack. So, I am comparing 85 with the stack top index element, that is A of 1, 80. Is 85 less than 80? Yeah, is 85 80 less than 85? Yes. Then just pop it out. Then just pop this element out. Now, compare this with the top of the stack, that is 100. Is it okay? No. 85 is not greater than 100. So, false. When the condition is false, what you have to do? You have to subtract this Ci minus the top of the stack. So, 6 minus 0, 6 comes here. Right? So, this is the solution. I understand it is difficult to understand the logic with stacks. I will once again repeat the solution for this. Let's try to understand this with another example. So, this is the array elements I have with me. Right? And we will take a stack. We will take a stack here. Right? And I am taking one S array. Okay. So, whenever you can just again you can take this as yes. Let this be A. I will name it differently. Let us make it a span array. This is our stack. Okay, right. So, what we are doing here? First, you put it 1 here by default in index 0, because for the first element we don't have any span. So, put 1 directly here. Okay, and place the topmost element onto the stack. Index of the topmost element, that is the first element. So, the first element index, I am storing it here. Now, begin the iteration. This time the control comes here. Start the iteration from index 1. So, the current index is 1 and the current element is 4. Okay, current index is 1 and the current element is 4. What you have to do? Compare this 4 with the stack top index element. What is there in the stack top index? It is 0. What is A of 0? 10. Compare this 10. Is it greater than 10 or not? Compare this current element 4. Is it greater than 10 or not? Is it greater than 10? No. When it is not greater than 10, simply put here 1. Simply put here 1. Okay. And place that element here. The index of that element here 1, like this. Okay. This is over. Next iteration. The current index becomes 2. My current index becomes 2. And what is the current element now? Current element is 5. Current element is 5. Okay. Now, what you have to do? Compare this current element 5. Check whether it is greater than, check if it is greater than the stack top index element. Stack top index element. What is there in stack top? 1. What is A of 1? 4. Is this greater than, is 5 greater than 4? Yes. Whenever 5 is greater than 4, you pop the element. You pop the element. Again repeat the comparison. Go. Again, compare the current element 5 with the stack top index element. with the stack top index element. Thus there is 0. There is 0. What is the value here? 10. Is 5 greater than 10? No, it failed. Right? Whenever we got it as false, the value as false, then whenever it fails, no, then you substitute the difference of current index minus the stack top index. Difference of the current index 2 minus the stack top value, that is 0. That you place it here. That 2 you place it here. Right? After this, what I have to do? I have to insert the current element 5 index, that is 2 here. Insert the current index onto the stack top. Again, let us process further. Now the current index becomes 3. So what is there at 3? I have 90. Okay, current index is 3 and the element is 90. Right? Then what you have to do here? Compare this 90 with the stack top index element. What is the stack top here? 2. What is A of 2? 5. So is 90 greater than 5? Yes. Then just pop out the element. Then again compare. Is 90 greater than the stack top element, that is 10? Is 90 greater than 10? Yes. Then again delete this element. Okay. How long you should do this process? Until the stack becomes empty. So what is my top now? My top is at -1. Once you reach the end, in this case, what you have to do? Subtract the current index minus the stack top value, that is -1, minus of -1. So this is 3 minus of -1, this becomes 4. So 4 comes here. Okay. And after that, I have to push this 90, that is 3, I have to push it here. I have to push the index of the current element, that is like this. Now my current index is 4 and current element is 120. Okay. Now again compare this 4, Ci, that is current element 120 with the stack top index element. What is there in the stack top? 3. What is A of 3? 0, 1, 2, 3, 90. Is 120 greater than 90? Yes. Whenever it is true, you just pop the element. How long should I do? Until the stack becomes empty. Now the condition fails. Why? Top became empty. The top value is -1. Then you do Ci minus the top value, minus the stack top value. That is 4 minus of -1, 5 comes here. Again. So what I have to push this 120, no? I have to push this 4 onto the stack. After every step, you are pushing that onto the stack. Again, next, my current index value is 5 now and the current element is 80. What is my algorithm here? Compare this 80 with the stack top element, stack top index element. So index is 4 here. What is array of 4? 0, 1, 2, 3, 4, 120. Is 80 greater than 120? Is 80 greater than 120? No. In this case, it is not true. When it is not true, what I have to do? I have to just just place it 1 here, and you can push that element onto the stack. You can push that element onto the stack. So 80 comes here. That is index 5 comes here. That's it. We did not have this. Sorry, this was not there. Only this was our array. Right. So we got the elements as 1, 1, 2, 4, 5, 1. See, 1, 1, 2, 4, 5, 1. Right. So this is the approach of stack span problem using stock span problem using stacks. Why are we using stack? We are using the stack to store the index elements only. Right. Let's see the implementation of this using the stacks. Right. So we'll be using implementing the stock span in C++. So we'll use the default statements. Right. So again, I'll be using the array logic for easy implementation. So I'll take I will define the hash value, some maybe 100 we can define. So I will declare int stack of m and int top is equal to -1. Okay. Now I have to calculate, implement the push and pop. We have this. Do we need push operation here? We don't need, right? I just have to create stack, and we are just popping out. We are just popping out the element from the stack, right? So we need to implement the pop logic alone here. Okay, so we will write int main, right? What I have to do here, I have to declare the array. So let that array be a of m, which I will be taking inputs, and also span of m, right? Why this? Again, this I want to do span, span index of size m, and I will give some int n, then I'll write cout, enter the number of days, or you can say number of days you can take, and you can take the value of number of days, right? Now you have to take the values. So some for I int I equal to 0, I less than n, I plus plus. Why I need this? To read the array C in A of I. These two lines will read the array elements. I have taken n, I have taken the array elements. After this, what I have to do? I have to calculate the span of a function. So maybe we can write some function calculate span. Okay, I'll pass the array A as the input. I'll pass the array A as the input, or maybe we can write it without function as well. Let's write it here only. Why to go there? Now I got the array elements here, right? We have the stack as yes defined here. Okay, so what I have to do? Initially the stack of uh, 0, stack of 0, that is no, I have to put the first element. What is the first element? A of 0, A of 0. Why am I doing this? See, this is one time activity. Stack top, right? We are putting the index, we are putting this 0, not A of 0, we have to put 0. Why? Because I am placing in the stack, the no, stack top contains index of first element. I have to this, right? Then, but I have to increment top, no? So yes, I will do this plus plus. Yeah, this is fine. Why? Top is -1. S of plus plus top means it becomes S of 0. S of 0 equal to 0, one time activity. Now in the span array also, what I have to do? Span of 0, I have to place 1 initially. This also we know, we have, while solving the problem, we have seen that the initially the span array will contain 1 for the first element. Now what I have to do? You have to compare. You have to compare the current index. You have to compare the current index, the current element with the stack top element, with the stack top element. So I will take some for loop for I, maybe for int j is equal to 1. Why I am starting from 1? Because already 0th element is fixed, no? So I have to start from first. So j is equal to 1. For j is less than n, j plus plus. Why I need this? Why I need this? Because I want to iterate it from the first element, no? Index 0. If the elements contains like this 100, 60, no? We have seen this example. Like this. When the elements are like this, you are comparing from 80. You are checking the 80 with the stack top index element, that is 100, right? So what I have to do? How long should I do that? While top value is greater than or equal to 0, and why? Until the stack is not empty, I have to do that. And the most important condition, what is the current element? How will I know the current element? That is there in J. That is there in J. So that is the array. My array is A. That is A of J. A of J. If this is greater than or equal to, which one? Stack top. What is there in top? Stack top. That is 0. That is A of like this. Okay. Sorry. See, S of top contains 0. I placed here, just now I placed it here 0. S of top contains 0. I am comparing that with that is A of 0. A of 0 means 100. A of j means 80. I am comparing whether 80 is greater than or equal to this or not. If it is not greater than, what we are doing, we are just reducing top minus minus. No, we are popping the element. We are popping out the element. So I'll make top minus minus. Else. Okay. So for this, while this is over, this is for comparing. Now, if the top value is equal to -1, it means the stack is empty. Then what I have to do? What should be your S value? Your span value? Span of this I. Span of I will be current I plus 1 in that case. Else again. Now, if that is not empty, then what we are doing, see, after comparing, if it is not matching, what we are doing, I will just go back here again just to explain you what we are doing. When we had some elements like this and you had a stack, you had the span array with you, right? We are taking current index and you are taking current element. If the condition is false, no, at some point it fails, what we are doing, current index minus the index of the stack top, that you are subtracting and putting it here, right, at the end. That logic I want to write it here. So we will write it, the span of I will be the current I value minus the stack top value. And last case, when this is not true, the last case we have to subtract. It means your stack top is always less than the current element. You pop it out. Again it is less than, you pop it out. Again it is less than, you pop it out. At some point it will fail. Whenever it fails, simply write span of I equal to I minus the current index I minus the S of top value. Sorry, we have to take J here because the element is J. Right? This is what we have to do. At the end, what I have to do? I have to, if none of this is matching, I have to just, after doing that, what we have to move that index. No, after doing this, see, after comparing this way, current element with the stack top, after comparing, some place it will pop it out. After that, you have to insert the current element onto the stack. So for that, I'll be writing stack of plus top is equal to j, right? So this will bring the element from the stack. So we are not using any push or pop operation. This is just the implementation of the logic. Okay. So this way I am inserting elements into the span. This is an int main. Now I have to print the values. For loop is over. I have to print the array elements. Which array I have to print? I have to print the span array. Right. So for some int k equal to 0, k is less than n, k plus plus, cout span of k. Right. Then we have written 0. Hopefully this should work. I'll explain once again this logic, what I have written here. We will first see whether it is executing. Span of j, sorry. Enter number of days, let's give the same thing, and then enter the values. So I'll give 100, 80, 60, 70, 60, 75, and 85. See, we are getting the span as 112, 2146. This is what we were getting as the answer. Maybe if you can replace this with right, enter number of days. So I give here 7. So elements 100, 80, 60, 70, again 60, 75, 85. See, 111, 2146 is the span. Okay. So let me go through the code once again. This is just to take the number of days. This is to read the elements of the stock values of 7 days or whatever number of days. Initially, you are putting the stack top, initially you will be putting the stack top value to 0, and in the span of 0 element you are putting 1. Why? Because for the first element there is no previous element. There is no previous day element for the first element. That's why we are initializing the stack of the top with 0 and the span value with 1. From 1, iterate from 1. What is the condition here? What is my logic of stock span? See, let us write the algorithm here, right? The logic. What is the logic here? Compare the stack top index element with current element, right? If that's true, means if this is no, the index element is less than, if it is less than the current element, what I have to do? If that is true, you just do top minus minus. You just move your top value, top minus minus. Else, okay, I'll keep doing this. If suppose the stack is empty completely, there is no element at all. After doing this top minus minus, if there is no element at all, okay, if the stack is empty, then what you have to put? You have to put your span value as that current index plus 1. Current index plus 1. The last case, what is that? Whenever it is greater than, the condition fails. If the condition fails, if this check condition fails, okay, what we are doing here? We are writing span is equal to the current index I minus the stack top value. At the end, you just insert every element. After comparing, insert every element onto the stack. So S of plus top is equal to I, right? So this is the logic we are doing. So we see here, I am reading the n value, reading the array elements, initializing both to 0 and 1. Then if until the top is having some element, or the current index element is greater than the stock top element, it is greater than the stack top element, till that you keep reducing it. If it is less than, delete. If it is less than, delete. That this while loop will take care. After this while loop, it means if there can be two possibilities, either the stock can be empty or it cannot be empty. If it is empty, just put span equal to j plus 1, or else put span of j equal to j minus current stop stack value. That's it. Okay, but because this while loop, either it may empty the current stack or it may have some value. So for that there are two if conditions, and after every operation you have to push that element into the stack. That's it. This is what we are doing here using stack. The number of comparisons is less here. Number of comparisons is very less to get the output. Okay, so this is the implementation logic. If it again take some values 10, 4, 5, 90, 120 and 80. See, 112451. We get the solution, right? So this is the implementation of this problem, stock span, right? So generally this is the input we are given. So we have to predict consecutively how many days the stock value was less than today's days. That is what this problem is all about. We are able to solve this using stacks.